Jai Hind everyone, myself Aastha Sharma from CSC department at Akgec Engineering College, and today I will talk about the trees and the graphs related to in data structure. So basically the trees, if we talk about in the form of the data structure, trees is like the hierarchical structure that is used to represent and organize the data in the form like of the tree like data structure. That is very easy to navigate and search within these the tree like structure. So it is the collection of the nodes, right, and that are connected by the edges in the form of the hierarchical relationship between the nodes. As you can see, like the trees structure is like it represent the number one, the node in the tree like structure represent the first node is the root element, and the root element has their two kind of childrens, right? So root element had the two kind of children we call the parent childrens, right? These nodes are called the parent children, and these parent children have their own two children, right? Each node represents the level of the node in the form of the tree like data structure. So why these trees is considered as a non-linear data structure? Because all the data is arranged randomly as per the data is given, right? So that's why we call the non-linear, whereas the arrays, linked list, stack, queue are the linear data structure, because all the data can be represented in the linear form way, right? So why it is called tree? It is called the non-linear type of data structure because all the data is stored in a sequential, not stored in a sequential manner. So they are sequenced in a form of the linearly. Instead, they are not arranged type in the variables, multiple type of the levels. So we can call it in the form of the in terms of the data structure, we call the hierarchical data structure, right? So for this reason, the trees are considered as to be the non-linear data structure, right? If we talked about the next, the basic terminology related to the data structure in trees. So number one, we called the parent node, right? So we have the parent node. As I earlier discussed, this is the root node, right? The very first node we called the root node. This root node has the two childrens, right? The two childrens in the terms of the parent node. So these two nodes represents the parent node, right? And these parent node has their childrens, right? So we called this children's parents children's called the left children's, right? And we call the right children's, same as the neighboring elements also, right? So if we talked about the number one, the parent node, so the node which is an immediate predecessor of the node that we call the parent node, right? Next we have the child node. Child node says it is the immediate successor of the node that is called in the form of the parent node, right? Next we have the root node. The root node, it is the topmost node, right, which represents the they does not have any parents, so we call the root node, right? And a non-empty tree must be contain exactly one root node and exactly one path routes to be followed between the nodes in the data structures, right? Next we have the leaf node. Leaf node, which means does not have any child node, or it does not have any neighboring element, that we call the leaf node. For example, in this diagram, if we want to represent where is the leaf node, so which means this child to the child have nodes which is called the only one node is present, and it does not have any neighboring element, that we call the leaf node, which does not have any child node, right? Ancestor of the node, any predecessor node on the path of the root, that node are called the ancestor of the node, right? That we call the A and B elements, right? Next we have the descendant, which means it is represent if the another node, for example, if we have the another node is Y, then Y is and the ancestors of the X. Suppose if you have A and B nodes, so which means B is the successor of the S, right? Next we have the siblings, which means the children of the same parent node, that is called the siblings of the element. Suppose this parent node has their two childs, right? Left and right child, which means the siblings of the nodes, right? Level of the nodes means this root node represent the level 1, right? This two nodes represent the level 2, then third, these four represent the level 3, same, this represent the level 4 and 5, right? Next we have the internal node, the node in which between the two successor of the nodes in the data structure we called, right? Next, there are few types of the data structure in. So it can be represented in the form of the number of the children's each node of the tree. So number one, if we talked about the number one type of the data structure in tree is binary tree. Binary tree says it has maximum 2 children, which means left children and the right children. So in binary tree, each node has maximum the 2 children which is linked to it, and some type of the binary tree that we called the binary tree or the complete binary tree, or we call the balanced binary tree, right? Or we can generate it with the help of the binary tree. For example, we have the BST and the binary heap. BST, which means binary search tree, right? Next type we have ternary tree. Ternary tree, it is the data structure in which the nodes, each node has their 3 children. Suppose earlier I told you that the node has only 2 children, right? But if we talked about the ternary nodes has their 3 children, right? The number one we call the left children, then this one called the right children, and the middle children we call the mid children, right? Next we have generic tree or N tree. Generic tree, it is the collection of the node that can be represent between the nodes. Each nodes in the data structure consist the list of the records or the reference of the children's, which can remove does not allow the any duplicacy in between the generic tree structures, right? So each node can be stored in a multiple times of the nodes. Next we have the basic operations of the tree. As we earlier discussed in the array and the linked list, the basic operation in the data structure we all know, like the traversal algorithm, right? Traversal operations, we have the insertion operations, we have the deletion operations, right? So all these operations we already know, right? So same as the operations can be followed up in the tree like data structure. So number one is that create, which means create a tree in the data structures, right? Insertion, which means insert any type of the data in between the nodes, right? Next we search, if you want to search any type of the data in between or in the sequence of the tree like structure. Next we have operation is DFS and BFS. So DFS and BFS, which means DFS is a depth first search and the BFS is called the breadth first search. So the difference between the DFS and the BFS is like if we talked about the DFS means depth first search. First it goes to traverse the root node, then it traverses to the first node, then it traverses to the last node. Then the last node traverses to the root node, parent node, then this parent node traverses to the right child, then right child traverses to the parent node, right? Then it traverses to the root node, right? So this type of sequence can be followed in the DFS, whereas if we talked about in the BFS, so BFS is like the visiting of all the elements, just like you visited in the marketplace also, right? The stalls are present. So first we go traverse to the root node, then they go traverse to the root left child node, then left child goes to the right child node, then right child goes to the parent left child node, parent left child node goes to the right child node. Sequence can be followed like this, right? Next we talked about the properties of the tree data structure. So properties of the tree data structure, we have the number of the edges, we have the depth of the nodes, we have the height of the nodes and the height of the tree. The number of the edges can be calculated by the n-1, right? The number of edges can be calculated by the n-1. So there is only one path from each node to the other node can be followed. Next is the depth of the node. Depth of the nodes is the length of the path that can be route can be followed, and each nodes can added with the 1 unit of the nodes while traversing any type of the data in trees, right? Next we have the height of the node. Height of the node defines the length of the longest path followed in the tree structures, right? Next we have height of the tree. Height of the tree, same, the longest path followed from the root to the leaf node, that called the height of the tree, right? Now the degree of the node. The degree of the node can be in the form of the 0 or it can be in the form of the 1, right? Or it can be so on. So if it has the degree 0, which means there must be the leaf node must be present. So the degree of the tree in the maximum degree among all the nodes of the tree is present, right? So next is the representation of the tree. The binary tree can be represented in the two form. The number one is the array linked list representation and number two is the array representation, right? So if I talked about the linked list, so earlier we talked about the linked list, the data can be represented with the help of the location and the pointer that points to the next element of the data. This is the linked list. So how you can represent in the graph, right, trees structures. So this is the simplest way that to represent in the binary tree. So the each node contain the data and the pointers to represents the left and right child in the node, right? The advantage is this, it is very easy to grow and shrink. So it uses only the memory that we needed, right? Because it is a dynamic approach, right? Next is adding or removing the nodes. It is very straightforward. Next is use of the memory of the nodes exist in a very efficient sparse trees structures, right? Next, we have the disadvantage. Wherever it requires only the needs to be present, memory needs to be present to insert the left or the right child. So this is one of the disadvantages, like is requires the extra memory, right, for the pointers. Next, we have finding a node that can take longer because you need to start from the root to the follow up to the pointers, right? So all the nodes can be represented in the form of the pointers in graph, right? Next, we have the graph array representation. Array, it is the one of the another way to represent the data, right? So it is very useful and it can be possible to the last to compute in this. So if you want to store the data, so this is the graph like structures, right? Each levels can be represented and data can be present in the form of the nodes. How you can represent this graph in the form of the array? Suppose the zero index always follow the root elements, right? So whatever the elements, whatever the data is present in between the nodes, so the zero indicates the root element. And if you want to calculate the left child and the right child, here is the formula. There you can calculate the index of the left child and index of the right child. So if you want to calculate the value, the index of the left child, you need to calculate 2 into I, which means any node, right? Any node at index, right? I plus 1 if you want to calculate the index of the left node, and I plus 2, 2 into I plus 2, which means the right node of the elements, right? Root node has the 0 index of the value, right? Next, we have tree traversal algorithm. It is one of the most important algorithm in university basis and as well as in the AKTube basis, right? Tree traversal algorithm followed the 3 algorithm traversal, right? Number one is the in order, the pre-order and the post-order. If we talked about the pre-order traversal, which means you need to traverse all the elements are present in the tree-like structures, right? So the pre-order structure followed up the policy of the root, left and right, which is already pre. So, right, suppose you have this tree-like structure like this, right? So if you want to print the element in the traversal order, first you need to follow up the root element, left element and the right element. So first if they print the root element, the left element, then right element, right? If you have more than nodes, right? So they go to the downs. First it follows the root element, right? It print the B, then it print the D, then it print the E. So B, D and E, right? This is the left child as per the policy, right? Then they print the this, right, as well as the right subtree and the root, right? So pre-order follow up to the root, left and right policy, which means it visited after the left subtree to traverse and finally recursively traverse until they reach the last node of the elements, right? The application is like it can be used to creation of the data, right? Copy of the data, copy of the tree, and it can be used in the prefix expressions, right? So the order of this expression must be A, right? After that, they can be represent all these data structures, right? Next, if we talked about all these can be applied in the form of the pre-order data structure, which means root print, then left print, then right element print, right? Above all these, the structure sequence can be followed like this: A, B, D, E, C, and C, F, and G. For example, you see A, B, D, E, then C, F, D, right? Next, if we talked about the post order traversal order, which follows the left, right, and root, which means first they traverse the left element which is present, then they sequentially traverse the right element of the present, right? And then the last they traverse the root element of the tree structures, right? So first the left root element can be traversed, after recursively the right, and after the root element can be traversed. After traversing all these elements, it can goes to the both the visited and the subtree of the element. The application is like this: it can be used in the deletion of the processes, and it can also used in the postfix expressions, right? The algorithm is this: first, step 1, you need to traverse the left child of the element, left subtree element, then you recursively go to the right child of the subtree element, and the last you need to recursive visit the root node of the elements, right? So the sequence of the procedure that can be followed like this. Next, we have the in-order traversal. In-order traversal follows the left, root, and right element, which means first they visit the element of the left subtree element, then sequentially they visit to the root element traverse, then recursively they go to traverse the right subtree element, right? So first they need to visit all the left subtree, after the root subtree, and the last they recursively traverse the right subtree. As the root node is traversed between the left and the right subtree, it called as the in order traversal algorithm, right? So each node must be visited between the subtree, and the application of this is it can be used in the BST, which means binary search tree node in increasing order, as well as it can also be used in the prefix expressions. Next, we have the various algorithm it can be implemented. The stepwise algorithm is: number 1 is traverse the left subtree, then step 2 is visit the root node of the element, and the third is traverse the right subtree recursively, right? So the sequence of the element, it can be first they print the B element, then they print the E element, then D, B, and E element, then recursively go to the root element, they print the A, and then they print the F element, right? F, C, and D, right? Next, we have the graph algorithm. So in graph algorithm, we have the 2 algorithm, which is most important for the exams purposes, which is BFS and DFS, right? So the graph algorithm, it is used to manipulate and analyze the graphs, which can be used in solving the ranges of the problems, right, to finding the shortest path and the cycle detection. Like the shortest path or the spanning tree, we have the Prism and Kruskal algorithm, and for shortest path we have Frolled or Warshall algorithm and the Dijkstra algorithm, right? So all these data graphs is one of the nonlinear data structure which made up a finite number of the nodes and the vertices and the edge that connect them between the order, right? So if we talked about the BFS algorithm, it is a traversal algorithm that starts from traversing the graphs from the root to the end, explore to the neighboring elements, right? It select to the nearest node and explore all the unexplored nodes. So if we talked about the application, it can be used for the location purposes, like if you want to find the neighboring location of the source locations, right, or the peer-to-peer networks in between the nodes, right? So the algorithm is like step number 1, you need to set the status 1, which we call the ready state, which means A to G element, right? Next, we have inserting NQ, the starting node, which means starting the node which is A, right? And set is to the status 2. Then repeat the further step until the queue is empty, right? Then sequentially DQ, yani in deleting the node of the N and process it to the status tree, which means the processed state, and NQ all the elements until you can find the all the elements can be visited, right? So the best way approach to solve the BFS, first this type of questions come. This is the directed graph because it shows the directions between the nodes. Next, you need to find the adjacency list. Adjacency list, which means suppose if I consider the A element connected, the neighboring element we need to find. So the connected element are D and the B. Sequentially, B is connected to the C also, and it is connected to the F. Simultaneously, C is also connected to the G and the E. So this way you can represent the adjacency list. After making the adjacency list, you need to find out the sequence, right? The sequence in BFS. So in this, we need to solve the Q1 and the Q2. So at first we need to, in Q1, first I insert or insert to the A element, and Q2 at present step number 1, it goes to the null. Similarly in Q1 A is popped to the Q2, and A, when it is popped, the neighboring element can be stored in the Q1, right? So A neighboring elements are B and D stored. Same step number 3, the Q1, the B element is popped and stored in the Q2 elements, right? So A comma B, right? Next, the Q1 store the neighboring element of the B. When the first element is popped, it is stored with the neighboring element. So B neighboring element is C and F comma D. Then same, C is stored to the Q3, and the neighboring element can be stored. Sequentially we can do, and we find the sequence of the elements. Next we have the DFS. DFS, it is the algorithm that is used to search all the vertices, right? All the vertices of the tree data structure. So the depth, it starts from the initial nodes to the graph until we go to find on the goal levels where they have the no children's or the no nodes was present, right? So the steps is, you need to create the stack with the total number of the vertices, then choose the vertices at the starting point of traversal and push to the vertex into the stack. After pushing it, the known visited elements can be present into the stacks, right? Repeat all the steps until you find the no vertices is there to visit the elements and on the top of the stacks, right? Next step is, if no vertex is left, go back and pop a vertex from the stacks and repeat all these steps until you find the stack is empty. So, right, BFS can be done with the help of the queue, right, and the DFS can be done with the help of the stack algorithm, right? DFS algorithm is, number 1, it can be used in the topological sorting orders. Number 2, it can find find the path between the two vertices. Number 3, it can use to detect the cycle of the graphs, right? Next step is algorithm. Here we have the step set the status 1, then you need to push to the all the elements from A to G, right? Next, pushing the starting the A and on the stack and set the status 2, which means the waiting state. Next, we have repeat all these steps until the stack is empty. Similarly, we followed in the queue, which is in the BFS. Queue is empty, right? Step number 4, pop all the top nodes of the n element, process it and set to the status 3, which is called the processed state. Then push all the stack to the neighboring element of the n in the ready queue state and whose is status 1 and select the status 2, which is the waiting state, right? End of all these loops. Here we can see the pseudo code related to the DFS, right? DFS, we have the G and the V, which is the graph comma vertex of the starting edges. Stack created the empty stacks, then for each vertex you need to visited U, which is equal to the false. If you want to push the S comma V, which is the empty stack comma the vertices of the graphs, right? So if it follows with the conditions like while S is not empty, then follow to and pop to the S, and if it is not visited, then visit the elements and come up to the conclusion true, and for each unvisited element the UU elements can be stored in the W and push all the element that can be stored in W n comma S, and if all these elements can be, all these procedures or the condition can follow in the while conditions, right? So this is the related to the BFS and the DFS algorithm. I also talked about the tree traversal algorithm, which is in order, pre-order, and post-order. These are the two questions which is important to the university level and the AKTU level. Next, I will talk about the shortest path between the two nodes, and I also talked about the spanning tree. Right. Next time we discussed about the Prism and Kruskal algorithm, Dijkstra algorithm, and Ford-Warshall algorithm. Thank you and Jai Hind.